The first thing that you want to do whenever you see a graph on an AP Calc question is to figure out what that is the graph of. And so what we've got in front of us is the graph of the function f. So what we know is we are looking at the graph of f of x up above here. Then they're telling us that we have this other equation, h of x, that is equal to this integral formula, -3 to x of f of t dt. I'll tell you this, as soon as you see any integral with a variable up in the top right here, you got to just be saying to yourself, this is really going to relate back 99 times out of 100 to the Fundamental Theorem of Calculus Part 1. So that's sort of a telltale sign as soon as you see that right there. Then let's see what the question wants to know. Then from there it wants to know on which of the following intervals is h increasing. So h increasing, what the connection you've got to make with increasing is first derivative is positive, greater than 0. That's what it means for a function to be increasing. And then you say to yourself, well, how the heck am I supposed to figure out what's happening with h prime when I'm looking at the graph of f of x? And again, that's where you got to remind yourself of this Fundamental Theorem of Calculus Part 1. I need to take the derivative of this side so that I can get an h prime equation, right? So I am going to ddx this side, and whatever I do to one side, I have to do to the other. And that's when we hit the definition, the Fundamental Theorem of Calculus Part 1 right there. And what that says is, it makes sense. Derivatives undo antiderivatives. A derivative is the opposite of an integral. They undo each other. It's like squaring a square root, right? Anytime you do that, those two things cancel out and you get whatever's inside. Well, taking the derivative of an antiderivative, same idea. So on the left here, we end up with h prime of x is going to equal, and then for this fundamental theorem, we just take and plug that x right in there and get rid of the integral. So then this becomes f of x. Now we have the connection we've wanted, which is h prime of x is the same as f of x, which means our graph over here is not just the f of x graph, it is the graph of the derivative of h. And so what we want to do now is read off of there the first derivative information. When you're reading first derivative graphs, anywhere the graph is up above the x-axis, that's a positive derivative, and that tells you where the original function was increasing. Wherever the graph is down below the x-axis, that is where the original graph would have been decreasing. And then whenever we have a 0, that's where it would have been horizontal and no change. So what we want right now is we want to know when does h prime of x, when is this increasing? So we want to know when is it positive. So we're looking for where is this graph up above in the positive y space. So we look over and our graph would be positive starting here at -3 and then all the way until we hit up 1 right there. And so when is it increasing? Well, now that we know we're looking at the graph of the derivative, it is increasing from -3 to 1, and our answer would be C. So the key to this was really remembering that, when you see these x's on these integrals, this is the Fundamental Theorem of Calculus Part 1, and even though it's an integral equation, it usually ends up working out to be something having to do with derivatives. And in this connection was that the derivative was the graph we were looking at. So then we had to know how to read the graph of the first derivative. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.